Hello, everyone. Welcome to the next episode of the Building Energy series, coming to you from the Global Energy Show in Calgary, Alberta. Today, we are featuring Aduro Clean Technologies, and joining us on the show will be Gene Cammack. He is a Chief Operating Officer, and Aduro is doing some fascinating work built around ways to address some of the pressing environmental issues faced in the global community today. So I'm going to welcome Gene. How are you doing today, sir?
Great to have you on the show.
Doing great. It's good to be in Alberta.
Excellent, excellent. How's the show been there so far?
Great show. Met a lot of people. Learned a lot of things, which is what you want to do in a show like this: is pick up as much information as you can, and some great meetings.
That's fantastic, fantastic to hear. And so we'll get into some of this information about Aduro. Going initially, could you just give a quick overview of what Aduro is trying to accomplish in the market right now?
Right. So, like you kind of mentioned, our focus has always been, how can we solve some problems that we see in the world? And one of those was, how do we take large hydrocarbons, and particularly we started around the bitumen market, and how can we make that more readily addressable? How can we get that to a more usable energy source? And so we started out working on that. The focus in the last year or two has been around applying that technology more in the recycled plastic market, because we see a huge opportunity to be able to take advanced recycling and do it at a greatly enhanced methods and economics.
So when you mention, that's interesting, when you mention about the plastics, is that directly related to like what you're doing in the bitumen market then? Did you come across that as you were working on that? If you just explain that part of it, that seems sort of unique.
Absolutely. So we came up with a process on bitumen, and the unique thing about bitumen, well, not unique, but it's basically very, very long hydrocarbons that have carbon-to-carbon bonds, kind of a long string of carbon bonds. And I know that's kind of gets into the technical side of it, but if you look at plastics is kind of the same thing. So that makes it very, very similar in terms of the chemistry. So the processes actually are identical. We add the same ingredients, we use the same catalyst, the same reactor setup, the same process, and it's just a matter of what we're feeding. We're either feeding the heavy oils, or we're feeding, recycled plastic, or plastic to be recycled, and then we get basically the same thing out the back end, which is really high purity product, ready to feed into either the fuels or the circularity market.
You just mentioned the circular market. So circular economy, that's a big word these days. So can you give more context on how that end product is going into both in the circular economy, and is it being used as well in the end product in the bitumen market too?
Not so much in the bitumen market. In the plastics market, the idea is we're taking fossil fuels, we're making plastics out of that. People consume those plastics, and then what do you do with them? You throw them away, you put them in landfills, whatever you can do with it. And the idea is to be able to take that used plastic and then convert it back into a feedstock that we can make more plastics with. And that's the idea of a circular economy. So suddenly, instead of having to put so much fossil fuels into it, we're just recycling what we have. It lowers the amount of landfill or incineration that we have to do to get rid of the plastics. And then it lowers the cost going back and the amount of fossil fuels we'll need to fuel that. So kind of good all the way around. So that's the circularity concept we talk about in recycled plastic.
Right. So I think of like for me, the recycling, you take bottles back to the bottle depot. So on your technology, how is that different from the regular market in that for the like developing that circular economy. Can you give some more detail on that as well?
Yeah, so plastics is a very wide market to start with. So it's there's a lot of different types, and some of those recycle fairly easily. In the case of, say, PET that a lot of bottles are made of, that's
Okay.
something that is fairly easy to recycle by fairly traditional ways. But a lot of the bulk of the plastic is in things like polyethylene, polypropylene, where those are extremely stable molecules and very, very difficult to recycle. So the first thing you want to do is, if you can get them clean enough so that they're still basically what they were before, then we can just turn those into new plastic feedstock. So if I'm polyethylene, I can just now make things out of polyethylene just like I would if it were virgin polyethylene.
Okay.
But a lot of times those get mixed up, and those get mixed with a few things that don't allow you to do that, what we call mechanical recycling. And so what's the option there? And you can only mechanically recycle probably somewhere in the 15 to 20% of all plastics. So we're looking at the rest of the plastics and saying, okay, how do we deal with these difficult ones? How do we deal
Right.
with ones that are not clean and dry and unmixed and so forth? And those are the ones that we're trying to address with our process. So it's kind of the
So
next level up of recycling.
So I do want to go back to the on the energy side, but so you're saying there an 80%, basically an 80% share of the plastics that needs to be basically implemented into that circular economy then?
No, at least. Total recycling right now is less than 15% of plastics
Really?
that are created.
So what would the process like? How you obviously did you set this up, like did you develop this out of a lab then, and then basically you would need to scale that up like significantly over the next decades to increase capacity then?
Yeah, we're certainly hoping it's not decades, but that's exactly the process. Is
Okay.
we've done extensive testing of it in the laboratory. We know what the chemistry looks like. We know what the yields look like for the most part. And we're in the process of moving that into what we call a continuous flow regime. So if you're going to make it commercial, we
Yep.
have to be able to continuously feed plastic or bitumen in and continuously get products out. And so that process is the part that we're working very hard on. By the end of the summer, we'll have at least a laboratory bench scale of that process, and then we'll scale up from there. And we're shooting for probably 2024, less than 2 years, having
Okay.
at least a pre-commercial process up and running.
Okay, well that's great to hear. So yeah, the decades is it's going to be way sooner than that is your plan. So that's fantastic. The you touched on as well like the molecules. So is there for the audience? So again, you developed it in the bitumen market. What is I'm trying to figure out how to ask a question from my end as I'm trying to understand it. The how does that work? Like separating those. You said there's more stable molecules that are they're harder to process. How are you able to develop that system?
Um, well, on the bitumen side, you're pretty much getting what comes out of the ground,
Okay.
one way or the other, and those are fairly uniform. If it's oil, it has a mix of different lengths of carbons, but they're all pretty much the same type of molecules. So those process fairly well. There's a lot of obviously nuances to it of things that you're getting with it, but those can be handled pretty straightforward. On the plastic side, it's a little more difficult because the process works really well on certain types of plastics, and fortunately, they're a large block of plastics that aren't currently being recycled well. But still, there's a lot of other plastics that we may or may not want to do that. Now we're pretty comfortable that there are ways to separate those out. There's new sorting technologies coming online. They're putting a lot of work into AI systems and making that sorting a little easier. Um, but we do think our process is a little more robust in being able to take a wider breadth of those polymers than others. So we still have to do some separation. We can't just take anything you throw at us.
Yeah.
But it's a little broader and certainly a market that there's a lot of plastic to be recycled that we can handle.
Have you done any projects or any like test trials yet with any customers or like any clients so far with this?
We've engaged on a number of clients and we've looked at their material. We haven't gone really in depth on what I would say is contaminated plastics yet. That's our
Okay.
next round of laboratory work, is to see how well we handle those contaminants. So
Right.
and we haven't scaled it to the point of really looking at partners to do that. The only one we've really done is a project that we did just kind of a proof of concept of what we were looking at, and that worked really well.
Oh, I see. Which sectors would be the biggest players? Like, it obviously would go outside of oil and gas, and then like do you get into like being your test facilities? Are they located in Alberta, or are you in a different province?
We're in Ontario. So
Oh, you're in Ontario. Okay.
Our main lab right now is in Sarnia.
Okay.
We've just signed a deal for a new laboratory in London, Ontario. So that's going to be our main focus for the R&D side of it, and then we'll move out from there as we need to, as we scale up.
And that's great to hear with the new lab that you're opening. So with that, are you increasing? So are you going to be running two labs and increasing the potential capacity then when these projects are starting?
The idea is to move into the larger lab that we're commissioning right now, and that gives us a lot more space to grow.
Okay, great. So you've kind of touched on it a bit for getting this, like getting to commercialization. Maybe you already answered this, but anyway, what are the next steps then for Aduro with that? What does that look like?
Yeah, so the next stage is, we're pretty much done with the laboratory, although you'll always be doing something. So the next stage is to move it into this continuous actual process. So all the equipment's on order, we're ready to scale up to that, and we'll be doing that through this summer at a slight challenge with some of the supply chains, as we all know.
Right.
But we've got all those lined out, we think, and by August we should be up and running with our continuous regime, which gives us the ability to really fill in all the gaps of how this is really going to work in a continuous mode, and then what the next stage needs to be. So then our timetable is run that reactor for a month or two. By the end of December of this year, we plan to have a design basis for the next scale up, which will move us into something that's really more designed around the commercial model, and then that will give us the next step on the scale curve, which then allows us to project how fast can we move from there, and learn a lot about what it's going to take to be commercial in and of itself. So that's the next step. We plan to be live with that hopefully by mid 23,
Right.
and then scale that to the next one, which will be the pre-commercial model of that, which will have a lot of the peripherals and be really ready to run all the way to smaller scale as a commercial unit. And then we'll get all the bugs out of that, and then we'll be ready to actually be building plants and putting them in service.
Like with this, on this scale, what sort of tons per hour do you need to get up to make it like to basically be at that commercialization, or is that part of the testing that you're doing now, like in the larger plant?
Some of that will be part of the testing, but one of the things we like about the process is it seems to be very scalable. And particularly in the plastics market, that's really important, because there's some applications where we think we can optimize this at about 60 tons per day.
Right.
But we also think that there's a lot of applications where we could be really useful at, say, 20 tons per day. And so we're shooting really for commercial at 20 tons per day now.
Yeah.
That allows us, because the plants are relatively small, we can put those close to the plastic sources, and then that lowers our transportation costs coming off and things like that.
Oh,
But it
so
also says the plants would be smaller because they're close to a single source of plastics.
Oh, I didn't realize that. So your plants are actually pretty. They're going to be easier to set up. So like if you have a depot where they're taking in, you could actually set up like conceivably thousands of these plants and have them in operation. So it cuts down a whole bunch of like the transport emissions and all that as well.
Right. So we envision these, for municipalities gathering and sorting plastics, they could put one of these plants in and immediately convert it to something more useful. And then you're moving into a liquid economy, which is much easier to put on trucks and pipelines and so forth and move around than it is to move bulk plastics.
right. The I
The process again. So did you learn like thinking as this relates to the heavy oil and the bitumen? Did you learn a whole bunch in the processing from that as well, and like how a lot of the operations for like at an oil and gas site, they're going to be there before it gets like trucked or pipelined out? Is that kind of where you came up with that model as well?
Oh, right. So the bitumen market's really unique, and you talk to people in Alberta, and it's they know it so well, and you're going, oh, I'm learning something every day with. But you're pulling very very heavy oil out of the ground. You're trying to get it somewhere else to be processed, and the oil here is so heavy that you can't just put it in a pipeline and move it around. So
yes.
they typically mix that with something lighter and then ship all of that down to someplace where it can be refined. And that's the overall economics say that, okay, if we could lighten that crude to where we could get it into a pipeline, then you don't have to mix the lighter uh, mixture with it, the solvent, and you can ship it down directly. So that's the big economic driver for doing that. It just makes it a lot more conducive to moving it into a mainstream, and then it gives you a lot more options in terms of where that oil can go. Right now, if it's very very heavy oil, it almost has to go to the U.S. Gulf Coast because they have the refineries that are capable of handling that. If it's a lighter crude oil, it would have options of sending it to different refineries
I see.
that may be closer.
So, Gene, going back again into the history and development as well, why was this process like? Why did you realize as well that this was going to be so effective? Like on when you were developing this technology, was there some core reasons why you thought this was going to be great for the market today?
Yeah, there's really three parts of it that are real differentiators in this process. The first one is the energy required to do it. Typically, when you're breaking apart large molecules, you have to get them very very hot, put a lot of
Right.
energy into them in order to break them apart. Ours uses a significantly less energy because it's done chemically. It's not just using heat to break everything. The second part of it is when you break hydrocarbons apart, you end up with a very reactive piece because you've broken it apart, something that wants to be bonded together. And so as you go back to those, if you just leave them unbonded, then they just randomly put themselves back together. So
Okay.
we ran a lot of experiments where, we got really great results, and then all of a sudden we left them overnight and we came back and it was a solid mess of something. And we said, well, that won't
Okay.
work.
Yeah.
And so the second thing we learned was how to quench those bonds. And so the traditional way of doing that in the hydrocarbon market is to use hydrogen to do that. So you put a lot of hydrogen at high heat, and the hydrogen then attaches to those. What we've developed is a new way to do that that doesn't require molecular hydrogen, which is really in demand today. It instead uses what we call an H source that creates that hydrogen within the process, and then quenches all of those bonds as we go through it. So we end up with saturated hydrocarbons, which is really stable and really nice. And we do that without using the hydrogen. So that's the second real advantage of the process. And then the third piece of it is because we're not cracking the bonds and doing that very randomly and ending up with a mixture of different hydrocarbons coming out. We have a very selective set of products that we get, and it's all saturated long or string hydrocarbons that are almost immediately fungible, right? So we can, depending on how we run the process, we can tailor that a little bit to a specific product. So if we want to talk about the circularity in the plastic industry, we can tailor that to where we're producing naphtha cracker feed, which immediately goes back into plastics. If we want to do something a little differently, we can tailor that down to the fuel market where we're producing diesel or aviation type fuel.
Okay.
But it all is almost immediately without any really additional processing, able to go through and you can immediately put that on the market.
So it's almost like if you take an old vehicle into the deal, like into a scrap yard, is it almost, you're making it the point, like whatever potentially the customer needs, you can actually refine the process to deliver that?
Right. So instead of putting it in a big shredder and just coming out with a bunch of different plastics and metal pieces that we don't know what to do with, we would go in and say, okay, let's kind of take these things apart. And I've got tires and I've got steering wheels and I've got this. And then I can sell those immediately out into the market, right? So I don't have to spend a lot of effort to get back to something that was valuable. And so, using that car analogy is a good way to look at it. If I put just a car in a shredder, then I end up with just a mass of metals and plastics and so forth. And yes, I could go through and eventually pull all that sorted out, but there's a lot of effort to do that. Whereas if I can just, disassemble it more succinctly, then I'll have the pieces that I can immediately go out and sell. So it's a good way to look at it.
So your process, and is the name, and looking at your background, is a process called hydrochemolytic? Is that
right?
Is that the name?
Hydrochemolytic.
Okay.
And obviously that came from our technical group. But it basically means we use water in the process, and that gives us, it helps the chemistry, but we don't actually use the water up as we go through it. So the hydro part is the water, and then the chemolytics is chemical deconstruction. So we chemically break these bonds apart and kind of cut the bonds and then reattach the pieces so that they're in shorter chains. So that hydrochemolytic is using water to molecularly deconstruct the hydrocarbons.
And that's how you're developing the hydrogen in the process to facilitate the separation, if I have that correctly.
No, the hydrogen is a separate device. So we add something, typically a bio-based. It can be things like glycerol, ethanol. Cellulose is one that we're really looking at right now because we've got a lot of waste paper that can't be recycled that we could use.
Right.
We add that to it, and that provides a hydrogen source for us without actually using the hydrogen itself. Got it.
Okay. Well, that is fascinating, and I definitely it's definitely a learning curve, as that it's still a part of the process, as you said, about the circular economy. I just want to make sure, we've covered a lot today, Gene. Is there anything else that you want to let the audience know and the viewers know about Aduro? And I just kind of an open floor to you, just to make sure we get any of those last parts in.
Well, I think that, basically we're a company that wants to solve these problems. And we think these are really significant problems to be solved, whether it's on the heavy oil side or on the plastic side. These are not easy questions to answer. There's not a single solution, a silver bullet that's going to come in and say, oh, we're going to suddenly solve the plastic problem. We know it's going to be a lot of different people working in this industry and a lot of very smart people coming up with solutions. We think we've hit on one that is a really nice piece of that puzzle, and we expect to be able to extrapolate that out and take a nice niche of that market with this technology. But it's certainly not going to be the the end all that solves everything. And we expect to work with people and work with partners and work with other technologies as well
Of
as we all
course.
try to fit this together. So we want to be part of that bigger picture and part of that solution.
And were you part of the founding team as well at Aduro, or what has your role been in, like, as chief operating officer? Like, what is your kind of like how did you develop into this role as well?
Well, I was not part of the original team.
Okay.
I did work with the chief technology officer who kind of came up with this process in a former life. He and I hit it off real well. I realized that he was really good at coming up with these kind of ideas. So when he
Okay.
approached me last fall and said, "We're really needing somebody to get this out of the lab and into commercial realm," I said, "Boy, that sounds really exciting." And the more I got into the technology, the more fascinating it becomes. So I came on board in December, and my job is really to move this thing, as I say, kicking and screaming out of the laboratory and into
Yeah.
the commercial world. And it's a fascinating thing. It fits my background real well. I've worked with both large companies and small companies. I've done a lot of capital project work. I understand what it takes on the engineering side to move these types of projects forward.
Right.
Um, so that's sort of what they're looking for me to do, is to pull together, a team that can really move this thing now that we've got the technology defined and we know what we're dealing with, to move it to something that we can continuously operate and really begin to solve the problems.
Okay, great. And then I'm guessing, like, shows like Building Energy and then the Global Energy Show as well. That's probably part of your broader campaign to, like, bring more awareness to Aduro then as well. Like, as you're
So we're doing two things. We're first of all trying to get more people to understand that this process exists and that it's going to be
Yep.
really interesting and exciting. And then we're looking for partners to help us get there. And so that's partners on, who could use the offtake of this process in their processes, who can supply feedstocks to it, who's interested in helping us develop it. There's, people that make products that we're going to have to use, so we're interested in talking to them. We know this is going to be a big, complicated team effort to get all this going, and so we're looking for people that we can work with and are interested in bringing this kind of a technology to the marketplace.
okay, great. For people that are looking to get into this sort of technology, and if they're hearing this, where's the best place? How do they contact you? Where do they find you?
Our website is adurocleantech.com. That's a nice place to start. There are
Perfect.
several people in the organization, and myself included, that welcome to connect up and discuss the technology and what they're trying to solve and what we're trying to what solutions we might have and how those might work together. We're always interested in understanding the problems, because those are the problems we have to solve, and in working with
Yes.
people that are interested in helping us solve them. So
Okay, great. And finally, you are publicly traded, correct?
yes, we are. We're on the Canadian Stock Exchange. It's ACT,
ACT is your ticker?
right?
Okay, great. So people can check out there for more information on that part of it. Um, okay, that is fantastic, Gene. Thank you so much for joining the Building Energy series. That was great, and make sure everybody to subscribe to the Building Energy series on YouTube. You can find that at Crownsman Partners, and also follow us on LinkedIn, Crownsman Partners, or the Building Energy series as well. There, give us a follow, and all the other social media channels. And that's great. Hopefully you learned a lot from this episode, and we will be back with more soon as well.